Who knows? I don't know. I mean, for that you have to read science fiction. I don't know. Read, look, Voltaire, as I'm telling you, that is Voltaire. This was in 17 something, I don't know. He wrote this book, Micromegas. Okay, look it up, Micromegas. It's a very interesting science fiction book. It's about these big people that come on the earth and they try to communicate to the little people that are there. It's very interesting that this man in the 1700s could think of something like this. Good, good, good. Who is this professor? You should give him something for this.
He's my dad.
Is your student?
Yeah.
Okay, so give him something for this.
Okay, some more question? Yeah, yes, please.
Mr. Professor, do you think it is possible to develop some neuron-like bioparticles to replace today's traditional computing system?
Well, so that's a different approach, okay? What you're asking is, can one make a biological type of, more like a working chemistry-based kind of a thing? That's what I think that you're asking, right? Right?
Maybe.
Well, I mean, you're asking, can one make something like to replace neutron?
Something about the possibility, if it's possible to develop some neuron-like bioparticles to replace today's traditional computing system.
Right, so you're asking, can one do
is
this?
There any progress in science?
Right, so, well, I mean, I'm not a biologist, so I have no idea, so I can't answer that question. My interest is in trying to replace that neuron, not with a biological-based system, but with a solid-state-based system. Now, whether it's possible to do it in a biological-based system, I don't know, maybe it is. I'm sure that biologists claim that it is possible.
He's still a condensed matter physicist.
I'm still a condensed matter physicist, and I still think, okay, let me put it this way, I still think that condensed matter physics is done more for the world than any other, well, perhaps not any other, but, you know, like X-rays. You know, think about it when you go to the doctor and you break your arm, that if it wouldn't be for X-rays, you know, you can forget it. That was, you know, a solid-state kind of a system. Think about lasers. Think about, I mean, there's hundreds of inventions like this. I think this is going to be another one of those.
Thank you.
Okay. More question? Last one question? Okay. Yes. Can you guess one? So,
Yeah, go ahead.
maybe louder.
Just go ahead.
You are a famous guy in exchange bias also, because when I was a master student, I studied the topic for exchange bias. I have a simple questions. When the ferromantic layer and the anti-ferromantic layer, if the anti-ferromantic layer can be lift up some distance, what's the distance? The intrinsic coupling will disappear. Yeah.
Okay, so he's asking, you take an antiferromagnetic layer, if you couple it to the ferromagnetic layer, the magnetization versus field loop shifts away from zero. That is called the exchange bias. Okay, so what he's asking, do you have to have them in contact or can you move it away? That's what you're asking, right? Yeah. Okay, so you can move it away. And you can move it away. It's of the order, it's basically a coupling which is an RKKY coupling across the so if you put a normal metal, who in fact the person that invented that was somebody who used to be here at this, who actually discovered that was who used to be here, was René Kuo, who is somehow related to this gentleman here. I don't know how she's related to you, somehow she's related to you, right?
Yeah.
Okay? And she discovered this, that there is coupling, there is exchange coupling across normal materials between two ferromagnetic, and this is true also with antiferromagnetic things. Okay, so it is true, and there's have been lots of experiments that they proved that actually you can put a normal metal in between there.
Yeah, the non-magnetic material in between.
Yes.
Yes, and what's the
well, it's typically, as I'm telling you, it's typically of the order of 10 to 20 angstroms. Okay. 10 to 20 angstroms, roughly, but that's depends on the material. You know, depends. If you put palladium, for instance, it's less. If you is more. If you put copper, I don't know. It depends on the Fermi surface and complicated things, but it's.
Come to see me. I give you the few classical.
He can give you all these classical papers. I don't know why he knows about this, but if he doesn't give you the papers, he gets beaten up tonight. Okay.
Thank you.
Okay, I think there's almost all the question.
I have last one.
Okay, that's one.
I mean, how come you're so good in getting funding? No, I know in the US, a lot of my friends, they told me that it's not easy to get funding.
Okay, so I'll tell you two answers to that question. So last year I thought there is no more funding for me, and I was ready to kill myself actually, because my funding will come to it. And then this year I went to the roof. So what's the secret to this? I mean, I came up with the secret to this. The secret is very simple. Okay, let me tell you a story. So a Jewish story. Okay. So Moses was a Jewish guy, was very religious, and he would go to synagogue every day and pray to God, and he would say, God, the only thing I want, I don't want anything, but the only thing I would like is to win the lottery. Not a lot of money, just a little bit of money. And then, his wife dies. And Moses goes to synagogue and says, God, could I just win the lottery once? And not a lot of money, a little bit of money, but could I just win once? And then his children die. Moses goes to synagogue and says, God, I really, you did all these things, terrible things to me. Can't I just win the lottery once? And so, and the rabbi is looking at him and sees this constantly. And Moses, all he does is he says, I would like to win the lottery once. So then the rabbi dies and goes up to heaven and meets with God. And the rabbi says to God, God, I have this guy down there, Moses. He believes in you, he prays to you. All he wants to do is to win the lottery. He doesn't want a lot of money, just wants a little bit of money. Would it be so terrible to just give him, let him win the lottery? God says, yeah, I would let him win the lottery, but he has to buy a ticket. So that's the secret, I think, to funding. You have to buy a ticket. In fact, if you want to win at the lottery, what you have to do is buy a lot of tickets. So I write a lot of proposals. So it's not like I wrote a proposal and it gets funded because I'm brilliant. I write 10 proposals, and out of 10, one gets funded, and that's the secret. So there is no real secret. I tell people this. There's no real secret. You have to buy a ticket.
Okay, then when your project gets rejected, don't complain to
No, you don't complain. No.
Please continue to write projects.
Exactly. Exactly, I don't complain. I just write another proposal. As soon as I get the rejection, tell my secretary, file this, write another proposal. But I write a lot of proposals, and that's the secret. And I think that many of your friends at Bell Labs, they think they're so important that they shouldn't be writing more than one proposal. Well, I'll tell you the story. When I went to San Diego, somebody asked somebody, how many proposals do you have to write? So what's the percentage? They said 10%. I said, okay, I'll make a fast calculation. I'll write 10 proposals, I'll get one funded. That was my calculation. And at that time, Paul Chu was at NSF. Now there was one area of physics where unquestionably I was the expert, was layered superconductors. I mean, no question about this, I was the expert in the world of that thing. So I wrote 10 proposals, 10. I wrote one proposal on layered superconductors and 9 other ones, even one in theory. I got 9 proposals funded, 9. There was one that I got it rejected. Was the one that I was unquestionably the world's expert. And I called up Paul Chu. And I said, Paul, what the hell is wrong with you guys? I mean, you know that I'm the expert in this. He said, yeah, just write another proposal. So that's the story. That's when I learned my lesson. Just write proposals. So I not always get 9 proposals. This was an anomalous thing.
Okay, this very inspiring colloquium talk, and also the many idea exchange with students, also the PIs, the faculty member here. So let's thank the Professor Schuller again.